So we're going to do 3 examples of testing whether a function is even, odd, or neither. I notice on this one, it's got an x squared, so it might be even, probably not odd, but it also might be neither. So remember, one test that we could do is plug in a negative x. So I'm going to replace these x's with negative x. And see what I get out. If I get out exactly what I started with, it's even. If I get out the complete negative version of this, it's odd. That would mean it has to be negative x squared and positive 3x and negative 1. Like if this happens, it's odd. If I get back to this, it's even. And if neither of those things happen, it's a neither. Okay, if I have a negative squared, this times itself is going to come out positive x squared. And then a negative 3 times a negative x is a positive 3x. And then plus 1 is just plus 1. So note that I did not get back to this. It was really close, but this is plus 3 and that was negative 3. So this is not an even function. I also didn't get this, so it's not odd. This would be a neither. If you don't want to work out these algebraically, you can just graph them as well, and let's check out the graph of this to see that it's a neither. So here is my graph on Desmos. Notice it is a parabola, it's got some symmetry, but it's not symmetric about the y-axis, and it's not symmetric about the origin, so it's neither odd nor even. Let's try another one. Again, I could test by plugging in negative x instead of this positive x. This negative is just going to have to hang out for now. Something negative cubed is going to come out still negative, because negative times negative times negative is still negative, so that's negative x cubed. And then negative 4x. So notice this one actually did come out completely negative of what we started with. If you wanted to think about like distributing this negative, you would end up with plus x cubed and plus 4x, which was exactly the opposite of what we started with, which was negative x cubed and negative 4x. So since it was exactly the opposite, everything was the opposite, this one is odd. Again, if you want to just try the graph of it, you can. Here's what that graph looks like. It's kind of cubed a little bit. There's a little swirly. But notice if you were to rotate it 180 degrees around the origin, you'd get the same graph. Okay, let's try this last one. Here's the graph of it. You may notice it looks pretty even. So it's symmetric about the y-axis. It's probably an even function. Let's test it algebraically. Again, notice it's got a lot of even exponents. So it's probably an even function. But if I were to try plugging in negative x instead of positive x, let's see what happens. Okay. Negative x to the 10th is going to come out positive x to the 10th. Because anytime you have an even exponent, it comes out positive. Because if I have negative x times another negative x, those make a positive. So each like combo of 2, this negative x makes it negative, and then this negative x makes it positive again. So each time you alternate positive, negative, positive, negative. So negative x to the 10th is going to come out positive x to the 10th. Same thing with this, negative x to the 4th. If I do 4 of them, negative times negative times negative times negative, that's going to come out positive x to the 4th. This one will come out positive x squared and minus 8. So notice, after simplifying, I got back to exactly what I started with. That makes this an even function. So on the practice, you'll have to determine whether they're even, odd, or neither. Feel free to use the algebraic test or just look at the graphs. And then based on that, does it have y-axis symmetry? This would just be like a yes or a no or a check mark. Or does it have symmetry about the origin? It might not have either. So fill in that chart for the practice.